In this tutorial, I'm going to show you how to import data and analyze it with Python and using the pandas package. So let's say we have some data like something like time here in a column, and then we might have some sensor data that we've read in, and in this case I'm going to have 8 sensors. Okay, so it's kind of like a table of sensors. I want to import these and then maybe take the average of those sensors, at least any good ones, so I might have some bad data in here as well, and take the average and then export this. Okay, so after it's imported, just this raw data, take the average and then export the combined table into another data file or back into something like Excel. Okay, so this is going to be the exercise. Let me just show you a couple things from the course website. So if you go to APMonitor.com and then go to CHE 263, and then on the right hand side we have the Excel and VBA. So we already did this example in Excel. So we imported the data and then took this average, and you can do that quickly in Excel. Sometimes when you're dealing with very large data sets though, or you want to do this programmatically versus in an Excel, we use something like Python. Okay, and so I'm going to come here to the Python side, and you can select data analysis here. I did a former tutorial on doing the same example but with just NumPy, okay, without the extra pandas package. And so for this one we're going to do it with pandas. So to get the data file for this, go ahead and just select this source code. It'll download a zip file, okay, and then go grab that from your downloads or wherever it is saved to. I'm just going to copy that onto my desktop and then right click it and extract all. Okay, so I'll extract this folder, and here I have an example script. Here's the solution right here that we're going to go through, but more importantly we just have these data files. Okay, so here it is in Excel, and if we just open it up, I'm going to click enable editing, and then I see that I have time and then my 8 sensors. One of the things that you'll see is that sensors 5, 6, and 5 through 8, those are not a number. Okay, so you can see those were bad sensors, and so I want to just take an average of these 4. Okay, you also see that time does not start at 0. Okay, so we're going to need to time shift that as well. I'm going to go ahead and close this. I've also got the data in just a data file, and that's just a text file without the headers. And I find that okay, so no headers there, but you can see the data in each row. Okay, I'm going to go ahead and close that. Or you have a CSV file, and if I right click this one and let's say just edit with a notepad, you can see this is just a text file as well. Okay, but it has the time sensor 1 through sensor 8, and then each row is a separate data point for each of those sensors. Okay, so I'm going to actually work with this data with headers because Pandas does a really good job with headers. Okay, so let's just go ahead and open up a new IPython notebook. Okay, and when that opens, then it'll come up with okay, here, and I'm going to go to my desktop. I'm just going to go to that same folder that I just extracted, because then I can access the data file. Okay, and so I'm going to select over on the right hand side. I'll go ahead and select new, and then a new notebook here. And okay, so this is just a blank notebook. I can rename it by clicking the untitled. Okay, so I'll just call this import data and analyze. Okay, so I'm going to import the data and analyze it. Let's go ahead and just import some of the packages that we're going to use for this. So first of all, I'll just import NumPy as NP, and I'll also do the same with pandas. A lot of people do PD for pandas, And then later I'm going to also import matplotlib and pyplot. But let's just go ahead and start with these two. So it's going to import those two, and then I'm going to go ahead and insert a cell below. Okay, and then what I want to do is now load. I'll load the data file. Okay, and so I'll just say data file. These are going to be my results. That's going to be equal to PD, and then I'll do .read CSV, and I'll do my data with headers.csv. Okay, I could also do read Excel here, and then do data with headers.xlsx. Okay, so that is the Excel file. But let me go ahead and just do it with the CSV for now. Okay, so I'm going to go ahead and import that. Okay, and then I'll go ahead and insert a cell below. Okay, so now I've got my data file, and let me just go ahead and let me go ahead and print a little bit of this data file just so we can see what's going on with this. Okay, so I have print data file, and let's say I just want to print the first just the first few rows of that. Okay, so I'm going to go from 0 to 3. That's going to be 0, 1, and 2. And then let's just go ahead and take a look at what it imported. Okay, so I have my time column, my S1, S2, S3, all the way to S8. And you can see the numbers there for some of those. Okay, now I want to parse this out, maybe make it a little bit easier for me to work with it. I want to exclude the sensors that were bad, for example. Okay, so let me go ahead and just grab time first of all. I'll say that is data file, from my data file, and then I can use the square brackets and just reference it by the column name from the header. Okay, and so that'll give me time, and let's do another one now, which is go ahead and parse out the sensors that are good. Okay, so we'll do sensors equals and then data file. Okay, and I'm going to use the IX, and that is going to go from all, say all the rows, and then I'll say what columns I want, and I'll go from S1 to S4. Okay, and then let me go ahead and just print, just so I can see what this looks like. I'll go ahead and print sensors, and I'll go just the first 6 rows of that. Okay, so it's going to be sensors 0 to 6. Okay, so I can see some of my sensors that I just printed out. So I have a new variable called sensors that's this table of just the sensor values. And now what I want to do is, I notice time does not start at 0. Maybe for the purposes of plotting, let me go ahead and just subtract off this very first time value right here from all of the time vector, or from all the time vectors. Okay, so actually let me come down here and insert. Okay, so I'll go ahead and delete that one, and oh, there it is, the delete. Okay, so now what I'm going to do is go ahead and just subtract off just that very first time. Okay, so it's going to be equal time equals time minus, and then we'll do time and just the very first value in that. Okay, and then let's go ahead and print time, and we'll go 0 to 3. Okay, and okay, so there are my times right there. It starts 0 and then goes to about 1 and then 3. So I don't start with some large value. I've subtracted off the initial starting value on that. Okay. Okay, so let's go to the next line here, and let's go ahead and take our average of these. So I want maybe I have 3 temperature sensors at different points in a reactor, for example. I just want to take an average of those at each time. Okay, so I could do that if I do average, and this will be the average of the row. Okay, and that's going to be numpy, and I'm going to use the mean, and then I'm going to take the average of my sensors, and then the next argument for this is over what index do I want to do this. So if I do 1, that's going to be over the column, so it'll take the average of the rows. If I do average with the 0 there instead of the 1, then it'll take the average of all of each column along the way. Okay, so let me go ahead and just print, and I'll do average. I'll just print the first couple rows of that, average row, and I'll go 1 to 3. Okay, and then I'll also print average on my column, and I don't think I need to condense that. That'll just be 4 different values. Okay, so there is, I had for my average for S1 is 382, S2, S3, S4, so that's the column average, and this is the row average that I just printed out. Okay, so I'm more interested in the average row instead of the average column, just for this example. Okay, let me go ahead and insert another one. Okay, so now what I want to do is now I want to put all of this information back together again, like I showed here, where you have you know, this average. It's on the right now. I've cleaned up. I've removed some of the not a number values, and I just want to put this back and then export it again. Okay, so the way to do that is just go ahead and create something like my data, and then I'm going to create a new array just with the different values that I want to put into my final data file. Okay, so I've got average, row, sensors, and time. Okay, and then what I'm going to do is I'm going to concatenate these. I'm going to put them together. So result equals, and then I'll do pd dot concat, and that will put them together, and I'll do my data, and I want to do it along the second axis, or axis equals 1, which will be take these column data and just put them left to right. Okay, if I did 0, then it'd be like stacking rows on top of each other, but these are stacking columns next to each other. Okay, and then when I do that, let me go ahead and just print result, and I'll just print the first couple rows on that. Okay, and then you can see I have my time S1 through S4, and then my average, which I hadn't given it a name for that column. It was just a NumPy array. Okay, now the next thing that I'll do is go ahead and just save it as something. So now that I have my data file that I want to export, I can do result and then dot to, for example, CSV file. Okay, so like where it came from, I'll just do result.csv. I can also do something like, instead of to CSV, I can export it to an Excel file. Okay, so that's XLSX. Okay, so I can export it to Excel. I can also do it to an HTML file. Let's say I just wanted a table that's exported to a web page. Okay, so there's HTML. Actually, I need to do HTML, even though my extension can be HTML or HTML. And then I'm also going to export to the clipboard as well. So when I run this, it's going to, and I don't have to give this a file name. What it'll do is it'll just put it out to the clipboard, and then I can do the Control V to paste it somewhere. I can paste it into like a Word document or something like that. It'll just put this data table out to a clipboard. Okay, so let me go ahead and save Go ahead and save this, and then let's go ahead and run this last line right here. Okay, and then it's going to export it. Let me go back into that folder so I can see a couple of these results right here. If I open up the Excel file that I just created, I can see all of my data with the time, the sensors, and then the average value. I can open up a it in HTML. Okay, so there it is as a web page. And then here is my CSV file. This is just a text file that's comma delimited. Okay, so I have all of my data here in this CSV file. Okay, and then alright, and then I'm going to show you clipboard as well. So let's say I wanted to open up Word, for example, and then I can open up a blank document. It's on the clipboard right now, so if I hit Control V, then it's just going to paste all the values in. Okay, so there it was in clipboard. Okay, so just a variety of different ways to export this. But let's say we also want to maybe plot some of these results as well. So just in order to use matplotlib and be able to show the values, here I'm going to do the %matplotlib inline first of all before I import, okay, and then I'll do import matplotlib.pyplot as PLT, and then let's go ahead and I'll go ahead and evaluate that, and then insert one more cell below. So now I've got PLT, and I'll just go ahead and create a new figure, and then let me go ahead and just plot some of these data points. I have time, and then I'll plot sensors. Let's just plot S1, and then plot that as a red line. Okay, and then let me add another one on here as well. I'll plot time and the average rows. Let's see what I name that, average row. Okay, so for every point I'm going to plot just one sensor, but then the average of all 4 sensors as well. And I'll do that as a blue dotted trend, and then let me go ahead and add a legend to that, and that will be we'll say that is going to be sensor 1, and then this one will be the average. Okay, so there I've got a legend for my plot, and we'll do an X label and a Y label as well. So this will be time, maybe in seconds, and okay, one Y label, and then we're almost done here. So that'll be sensor values. Okay, and then let's also just save this. So I can view it here, but I also maybe just want to save it as a PNG file. So I'll go ahead and export my this plot that I'm creating, and I'll do that with the save fig, and I'll just say myplot.png. Okay, and I think I am done now. Okay, so let me go ahead and just execute this. I can see the sensor 1, the average values for that, and then let me go back into my directory where I'm working, and it has myplot.png. So here it is, in PNG format. You can import that, for example, into a PowerPoint or other presentation format. Okay, so I think we're done with this script now. Let me just go back here to the okay, so just to review, what we did is we just imported NumPy and pandas. On input 2, we just read the CSV file, just displayed some of the data, the raw data, just the first 3 rows, assigned this as time, then just parse this. We sliced some of the data. I just took sensors 1 through sensors 4, and then reinitialized our time to start at 0. We took some averages here on the row or column-based averages, and then put the data back together again with the row averages, and then exported it to a CSV file, to Excel, HTML, or clipboard. And then we, as a final result, we just plotted some of our data. Okay, so that concludes this tutorial video. If you're having a hard time with some of these with pandas, don't, or NumPy, it just takes a little bit of practice, but then it'll be intuitive. It'll actually probably be faster than something like Excel if you learn some of these commands. There's a lot of other commands in pandas. I've just kind of given you a very, very basic introduction. It's used extensively, for example, in the financial analysis sector or others, but engineers and scientists also use it as well.